Okay, so this is the link to the Discord. And let's get started. So welcome everyone to Introduction to Mars. So I'm going to discuss the agenda first, and plan for this talk is very, very simple. First, I'm going to give you Introduction to Mars and kind of like high-level overview. Mars comes with a set of very highly customizable templates. So to help you get started, you can use these templates, and they're great as a learning resource, and they can really accelerate your development. So there's going to be a second topic. And finally, I'll talk about creating dynamic content using a rule-based workflow. That's a little bit more human-friendly. It's a relatively new feature to Mars. And after that, we'll run a quick Q&A session to answer all your questions. And to respect your time, I try to wrap everything in 1 hour. Just in case we run out of time, maybe you watch this talk offline, we'll continue the discussion on Discord. So what is Mars? Mars, first of all, stands for the Mixed and Augmented Reality Studio. And it's a set of specialized tools and workflows for creating intelligent AR experiences. And our goal here really is to allow creators develop AR applications that they really, really want. So as a developer, you shouldn't be limited by your tools, right? So editor shouldn't be a limiting factor. And you should be able to create experiences close to what you have originally envisioned. And Mars was designed and developed to target several different use cases across different industries. So, Unity started as a game engine, but now we try to target many different verticals to allow them to create, AR applications in a more user-friendly and efficient way, because not everyone is a programmer. Sometimes it's better to have this more visual, human-friendly workflow. So in the industrial environment, Mars can allow you to create tutorials and things like guided support. We have a very, very nice factory example as one of our templates that can be like a starting point for tutorial and guided support. In mixed reality, you can use it for previewing and maybe for e-commerce, the consumer applications where you can preview items, a consumer can preview items in their preferred environment. Of course, because it's real-time engine we're using Unity, you can add some more interactivity. You can include some storytelling. Another use case could be IoT and using your mobile device to control connected IoT devices. So why do we need Mars? It's a question you might be asking right now. So what's the problem that it solves for you and your team? To build a solid AR application, you need to work with real-world data, right? Because augmented reality just augments the real world. There's no question about that. And after you create your base application, you have to set it in a real-world scenario. And there are many situations that are very hard to predict. Real world is very unpredictable. And there are many different variables that come into play when your application is distributed, maybe, like on App Store to millions of players, millions of users. Each one of them is going to use your app in a slightly different, unique way. Maybe in a room, maybe in the outdoor environment, in a different lighting condition. So there are a lot of variables that come into play. And Mars enables you to work with this real-world data and build your application around that particular scenario. So that means you can work instead of deploying every time you make a small change and deploy your application to the device. You can use a simulation environment. I'm going to show it to you in a moment, and this really allows you to speed up the iteration time. So it's kind of a pain points in the development where you have to rebuild your application, put it on a device, and just takes a lot of time. So with the simulation environment, we allow you to make this stuff much, much quicker. The iteration time is way shorter. And when working with simulation view and device view in Mars, as I said, you don't have to rebuild it every time you make a small change. And when you want to test it, you don't have to, bring your device on site, maybe on a construction site. You can do all the changes and test it from the comfort of your own office or maybe home office, your room. And everything is testable from the editor. Mars provides a proxy authoring framework, and this allows you to define how your device is going to perceive the actual world. And the name of the feature is the fuzzy placement. And instead of placing your augmented objects, like maybe ladders here, or maybe this rocket, instead of kind of hard coding them, placing in the fixed position, you can use them in a more kind of higher level of abstraction. So instead of saying place ladder on this particular element, you can say, please find me a table. And what is the table? We are going to use this notion of a proxy that defines what the table is. So the table could be a surface that's minimum 30 centimeters by 30 centimeters, maybe 40 centimeters above the ground level, above the floor. So this is a proxy, right? It's something that represents maybe a chair, table, and it's more kind of procedural, nice way of dealing with stuff. So how does it work? As I mentioned, Mars is a specialized work environment inside the editor. Okay, so most of the stuff is going to happen in the editor. And it includes many different tools and UIs to give you ability to, prototype, test, and eventually deliver all this cool AR experiences and applications that you have to create with a much more nice and streamlined workflow. Okay, so I can see that we have already quite a lot of things in the Q&A. Let me see if everything's fine here. All right. So let's take a look at the editor. It's slightly different from your default view, but bear with me. I'm going to explain just very quickly, and then I'm going to jump into the actual editor. So what's happening here? There are a couple of windows that you should recognize already. So starting from the top left corner, we have the hierarchy with a list of game objects. Then we have the scene view. In the scene view, you can basically visualize all the objects that you have, and you can place them accurately in your scene. All right, and when you select any object in your hierarchy, then we have the inspector view, and in the inspector window, we can adjust all different parameters for your objects. And as you know, Unity is built around this component system. So each game object has different components. By default, each one of them has a transform, but you can add, like a proxy and different type of components. And a place where you can adjust them is the inspector. Then we have the project window with all your assets, like textures, 3D models, prefabs. You can drag them into your hierarchy or into your scene. But this is something you should probably already know if you are experienced with Unity. So what's new? We have the Mars panel here on top. You can see that we have that kind of serve as like a shortcuts for different Mars-related objects. So starting from the top, we have presets like horizontal, vertical plane, image marker, face mask. Then we have the primitives. Primitives like proxy object, proxy group, replicator, synthetic object for testing. And they are really like a basic building blocks for your experience in Mars. And the presets, they're actually built out of the primitives. Then we have the visualizers. So visualizers like plane visualizer, point cloud, the facial landmarks, they are all available from here. And they are very good for debugging and letting your user know what's happening. Maybe if you run the plane detection and the planes gradually expand, then it's very valuable visual feedback for your user that tells him, hey, we're actually doing the plane detection here, and there is some progress in the application. Then we have the simulation controls. So they basically control the simulation view, and we support all different simulation environments. I'm going to show you that later. We support scenes, scans, photogrammetry, video recordings. That's really, really nice. Then we have the content hierarchy, and this really shows you the list of game objects that are being currently simulated in your simulation view. Okay, and there are some icons here. I'm going to explain you later what they mean. And yeah, Next, we have the environment hierarchy, and here is a list of game objects in the simulation environment. And it's very similar to hierarchy window, but it's not like real game objects in a scene. They are only related to what you have in your simulation environment. So this would be like a dining room here. If we switch to like a factory, this will be replaced with a factory. And you can, we also have a device view and the simulation view. And you can think of them, simulation view is kind of like your scene view, and device view is kind of like your game view in the simulation environment. So simulation view, it's used to test your content against some synthetic data, like this dining room is a synthetic kind of 3D environment, or it could be like, recorded video. You could place here some room surfaces and so on and so on. And this really reduces your need to recompile your app, and you don't really need to test it on the device. So if the simulation view was like a scene view, the device view is really like a game view, and it's basically like a sub mode of the simulation view. They are very similar, and you can use device view to test your application from the perspective of the camera. So here in the simulation view, you can kind of preview it from any angle, but device view is always going to be from the position of your camera. So it's kind of simulating maybe your handheld device, your phone position, and it's kind of viewport. So device view is just for that. So AR applications, they are meant to be, many people forget about it. They are meant to be used in the real world. And it's hard really to define all different potential variables that can come into play. So maybe your main team is based in the US or Australia, but houses in US are very different from homes in Singapore, Australia, or Thailand. They're all very different, right? And even within the same regions, users, they're going to encounter different conditions. So maybe rooms can be rearranged, chairs in a different position, some lighting conditions, they're all going to be different. So Mars, it really solves some of these core AR development problems by allowing you to test against multiple different environments. And in the simulation view, you can test your applications in a kitchen, in the synthetic outdoor environment, and you can very easily see how it's going to behave in all those different conditions. All right, so Unity Mars, it enables you to take into consideration all those different variables, and also provides you with this nicer visual workflow, so you don't need to write any code, and it lets you move through the prototyping phase much quicker than it was originally done. With very little coding, but of course, if you are a programmer, or maybe you have a programmer in your team, you can go to our manual and see all these different examples, how you can extend your Mars application. The basic idea here in Mars is the proxy-based workflow. So the proxies, as I mentioned before, they represent this real-world concepts like a chair, a table, a bed, window, and things like that. And users are able to set different conditions and actions to tell them, how applications should behave when you encounter that proxy. And we have this fuzzy offering that allows you, to fit your application to many different scenarios. So maybe bed, instead of having just one size of the bed, you can set the minimum bounds and the maximum bounds, so to allow for some flexibility in your application. And one of the best features really is the ability to use the simulation view to create your app in a really more intuitive way by kind of dragging and dropping different objects onto your planes. And Mars is going to automatically create appropriate proxies for you and some conditions with reasonable values. And testing your app in every location, as I mentioned, it could be close to impossible. And that's why we allow you to test it in a different environment. So here we have the simulation view and the device view. So you can see the device view is kind of like a view from your phone, right? We can move it around. It's just using AWSD on your keyboard, right mouse button. And then the simulation view is like your scene view, right? We can kind of look at our simulation scene from a different perspective. One thing to notice here is that the planes that we detect, you can notice that they are very imperfect. So you might be asking why we don't make this simulation here perfect. And the reason why is because the devices that we use now for AR development, they are imperfect themselves. So this is something we try to simulate here to make it more realistic, to simulate it in a very close way to how a final application will look like. So yeah, the iteration time and time required for testing can be vastly reduced. The environments I'm going to show you today, they are mainly indoors, but nothing stops you from testing them in the outdoors environments or using some custom assets. So maybe scanning your office. I actually scanned our Unity Singapore office, and I plan to create like a quick demo with our office as a simulation environment, but I didn't have enough time to prepare it for today, unfortunately. And yeah, it's sometimes it's challenging to make digital content feel like it's like you're interacting with the real world. And one of the amazing use cases that we have is this application from Sugar Creative. We actually had a webinar with them, and one of the developers and the main kind of creative people were talking about different challenges and how they resolve with Mars. So for this particular application, some of the features that were used were plane occlusion, floor finding. So there's this kind of semantic values that you can check against. So if you, let's say, want to spawn some maybe this camel or grass only on the floor, then you can add a condition on your proxy to only check against the floor, and then Unity Mars also ensures that the digital content reacts to the physical world in a more believable way. So one of the most common use cases for AR is to scan an image target and do some augmentation on top of that image target. So here you can see that it's a bolt attack, and it's on the phone. It looks very, very seamless, right? I think part of that is that there's this nice white frame both on the target and on the 3D object in your scene. So there's this nice blend between virtual and real. And finally, one of the final parts of the workshop is going to be the rule-based workflow. And it's a relatively new feature of Mars. It's a new visual way of describing behavior of the application. And as you can see here in the screenshot, it's almost like reading English. So it's like on every horizontal surface, spawn this object on closest point to the camera. So it's really, really nice, human-friendly way of creating behaviors. But enough talking. Let me switch to the editor and show you how we can actually do all of that. So I'm going to start with a basic setup. Mars, when you get access to Mars, it's going to come in the form of a package. And so once you get Mars, you'll be able to locate it in the package manager. There is a Mars package, Mars NavMesh package for navigation, and also some AR-related things like Mars AR Foundation providers. All right, and now to speed up your development time, we also provide you with very convenient and useful templates. So if you go to Window, Mars, and choose the Choose template, you can see that we have a couple of them here. However, there are only 3 that come here out of the box. If you want to get more of them, you can come back to the package manager, select the Mars package, go down here to the samples under dependencies, and there is this Mars sample templates. You can click import. It's going to take a couple of seconds to re-import all these assets, and you should be good to go. So now let's come back to the window, Mars, and choose template. As you can see now, we have much more of them now, and I'm going to start with the game simple. So it's just a very simple game in which Mars is going to spawn some collectible objects. So they're going to be these blue crystals, gems, and it's going to spawn one playable character, which is a robot. We call this robot Unity. It's Unity robot. All right, so I'm interested in the game sample the most, so let's start that. After clicking, it's going to load it into my environment. And if I would press play now, you can see that in my game view. I'm going to maximize it. I can move my camera around. So I'm using AWSD and my right mouse button. I can navigate around the scene. And as I move closer to the objects, the simulation is automatically simulating the plane detection. So gradually we expand the plane. And once the surface of the plane is big enough, the game sample is going to spawn these different blue crystals in the scene. And on one of them is going to spawn our Unity robot. Okay, and I can use my finger. When I build the device, I can use my finger to tap to move it anywhere. Here in the editor, I can use my mouse to click to move, or hold and drag to kind of navigate around the scene. So that's very nice. And I built it, I saved the scene. I added the scene to the build settings. I built it to my device. So this is a quick video from our Singapore office. And you can see that as I move my phone, it builds the planes gradually and spawns different, these gems, crystals around the scenes. And when you tap anywhere on the screen, he will follow and collect these crystals. And what you should really notice here is that the planes, they automatically occlude 3D objects out of the box. So when I tell our Unity to go under the table, he should be occluded by the plane, by the table plane. All right, and at the beginning of the presentation, I mentioned several editor windows. And if you're new to Unity, you might not be familiar with the notion of layouts. So they are very nice, and they allow you to quickly switch between maybe your layout for developing 3D game, 2D game, and maybe AR application. So it's going to speed up your development. I'm going to spend maybe 2 minutes describing that. So here on the top right corner, we have the layouts menu. And if you click on it, you can choose kind of the predefined that we already have in Unity. So let's close that window here. I don't need animator. Let's go to window, open the Mars and the Mars panel, and let's dock it somewhere in a convenient way so I can access it easily on the left-hand side. Maybe here on the left to make a bigger area, and come back to window, and again, go to Mars, open the simulation view. I like to keep the simulation view here at the bottom so I can easily access scene view and simulation view. And the simulation view is something that you're going to utilize the most throughout the game. So yeah, you can keep it relatively big. And once this is done, to kind of speed up switching between them, you can save your layout. You can give it a name. For me, it's Mars layout. I'll save it. And now, anytime I can very easily switch between my preferred default layout and the Mars layout. And it's just that simple, and really can improve your kind of quality of life in the editor. All right, so as I mentioned before, simulation views, they're like scene view, and by default they come with many different environments. So it's really nice and allows you to switch between maybe this outdoor backyard, indoor bedroom, and maybe you don't have any like a big kitchen or outdoor environment next to you. Right now with all the lockdowns and the restrictions, it's very hard to move around. So this kind of simulation could be a real lifesaver. So let me select the bedroom and test it. I really should be doing this in a device view, but just for the clarity, I'm going to maximize the game view so I don't have any other elements on the screen. And you can see that when I enter the play mode, it's gradually expanding the planes. And after we have enough data, it's going to start spawning all these different gems and my character. And the behavior is going to be exactly the same as I shown you before. So if I click anywhere, the robot will follow. You can check out the how it was scripted, how the behavior of the robot works. So it's nice and all, but how can you start your own project, right? What if you want to do something slightly different? I'm going to walk you through the proxy setup that's going to allow you to create your own customized version of this AR experience. So let's start with conditions. So I'm going to disable all those different plane visualizers and other game objects. You can see I have here, just for the clarity, I'm going to set them to be inactive to kind of unclutter my my simulation view. And I'm going to start by creating a proxy. So I can click here in the primitives. I can select Proxy Object. It's going to spawn a new one in my scene, and you should also see it in the hierarchy and content hierarchy. Currently, it says that, and I can also right-click in the hierarchy, go to Mars, create a new proxy object, and the result is going to be exactly the same. So currently, you can see that we have a message that no match found, and we also have this icon with a bar crossing this gizmo, and it says that we didn't find any matching surface in our scene. And you can read the message here that we don't have any conditions assigned, so we can add a new condition, the plane size condition. And now when this condition is met, we are going to find a matching surface. So here it's kind of matched it with a ceiling, but of course this is something we can easily modify. So from here, in my scene view, for example, I could kind of zoom in to that particular gizmo, and I could click here, edit conditions, and set the minimum bounds. So this is very easy to do and very intuitive. I could also set the maximum height. So any surface that's within these bounds is going to be detected as a matching surface. So for that particular proxy, it kind of matched it with this bin. And we can tell that it's matched because we see that blue gizmo over there. Right, and let's add a new condition to that. So here it kind of matched it with the ceiling, and I'm going to add alignment condition. So add Mars component condition alignment, and by default it's set to horizontal up. So it's only going to match our proxy with surfaces that face upwards. You can also set it to vertical. You can kind of mix and match, make it both horizontal and vertical. So this is really powerful and allows you to kind of fine-tune where you want to spawn that particular content. And I think I didn't mention that, but I also dragged the crystal prefab under the game object, the proxy object, so that every time this proxy is enabled and matched with the surface, matched with the plane, it's going to move to that particular position and move there. So if you select your proxy and go to the compare tool and click on compare in simulation view, this is really powerful. And you'll notice that as I hover my cursor around different surfaces in the simulation, they become selectable. And when I click on them, Mars will compare, the size and different things. And if the conditions are not met, it's going to highlight them in this red font here. Okay, and from here we have two choices. We can either include, the orientation and all these different, maybe the size, or we can click optimize. So if we click optimize, as the name suggests, the conditions for that feature, size, orientation, they're going to be optimized to fit that selected surface. And if we click optimize all, okay. If we click optimize all, Mars will perform the same action, but for all the conditions in that proxy, there'll be a pop-up window with a warning, and the previous settings are going to be discarded. So be careful with that one. Next, let's take a look at the include. So most likely we'll use this one more often than optimize. It's less intrusive and adjust the conditions to include the cases from selected surface. And include all will do the kind of similar thing. It's going to apply include to each condition that you have. And again, be careful with that one because it's going to override. We have a wording here. Okay, so in the previous part, I've shown you how to add conditions to your proxies, and there are much more conditions I didn't talk about, like the elevation, but I don't have enough time to mention all of them. So at the end of the presentation, I will share some links with you that's going to aid your learning process. Let me actually share it now. So in the chat, I'm posting now the link to the documentation. And documentation has all these different conditions and cases described there. Okay, so now let's talk about actions. So once we detect the proxy, once we detect the surface, we can perform certain actions on that proxy with the matched surface. So let's select the bed and optimize conditions to match the size and elevation and all of that. And what I'm going to do now, just for demonstration purpose, I'm going to grab that crystal that I have here. And I'm going to duplicate it a couple of times to kind of be more expansive and cover the entire surface. So I'm really just, doing Control D on Windows. It's Command D on Mac, and I'm duplicating all these different crystals so that every time I detect the bed, what will happen is that we spawn a bunch of crystals at the same time. So it's really not ideal because, as you see in the simulation view, crystals now, they kind of extend over the bed, right? They don't fit in the bounds. So what we can do here, we can create a new action. I'm going to filter by actions. And we can go here to add Mars component, select action, and show objects in bounds. So this is a very simple action that's going to trim all the game objects that, rendering bounds, they kind of exceed your detected surface. So that's extremely useful. And allows you to, basically make everything appear as it should. Again, there are much more actions that I didn't mention yet. You remember at the beginning, I disabled this elevated surface game object in the plane visualizer. So let's set it to active and see what it does. Let me filter the condition here. I'm looking for the height above the floor condition. So it means that, once the condition is met, we will spawn an object attached to it. And we have this detacher script, all right? And basically what it does, it detaches from the parent transform, the robot. All right, so yeah, that's basically it. It's our robot here, the Unity. You can see it right here in the content hierarchy as well. And it's all good, but so far we were spawning only one prefab at one surface. But what if we want to spawn one prefab on multiple surfaces? We can use a replicator component for that. And I have here the put colliders on all walkable surfaces. And as the name suggests, it's going to put colliders. So we have this replicator here, all right? So replicator means that it's going to replicate itself over and over. And as a child, this replicated object, we have a proxy. And the proxy here is set to match surfaces. It has a build surface action. So it's going to build this walkable surface together with the mesh collider. And you can see it's being duplicated here all over the matching walkable surfaces. We know it's a collider because it has this green gizmo, green lines. Yeah, and it's created a nice collider for our robot to walk on. And the last one I will show you here in this section is the replicator for the crystals. And let's re-enable it. And yeah, it's a very, very similar story here. So on a horizontal surface, we are going to spawn a bunch of crystals that are going to be kind of contained in the bounds of the surface. So, you know, our robot can then collect each one of them. And we can make sure that, you know, these surfaces are walkable. We can walk through them in the content hierarchy. All right, so you can maybe think that, you know, it's quite a lot of setup for all these different proxies. And the good news is that the workflow can be much simplified. So in Mars, we have this concept of automatic proxy. And if I drag and drop a prefab on the surface, you will see that there is a new dialog that will automatically detect the size, the elevation of the surface, and give me some reasonable defaults that I can use. And it's going to create all the matching conditions like alignment, the plane size, height above the floor. So yeah, that's here. We have all the matching conditions, and we just did it by dragging and dropping our crystal on the surface. Of course, it's kind of like sank into the bed now. We could kind of lift the object up, but that's just pure visual thing. And the last thing in this template that I want to show you is the one from the factory training. So let's select this one here. I don't want to save the scene. If you work on a real project, make sure you save it. And here in the simulation view, I'm going to select the factory environment. You can see that it looks kind of like a warehouse, maybe a factory. And what I can do now here is I'm going to show you what kind of example we've included. So let's press play and see the training. So we have this nice kind of dialogue here with a description. It asks us to follow the marker here. If we come closer, it's going to detect our position, and it kind of simulates the real training that you can maybe create for your employees that work in a factory. We have the image marker detection to align the virtual world with the physical world, and yeah. So if you come from AC vertical, this is a great use case, and I highly encourage you to check out our factory template. And the last thing, really, before the Q&A, I'm going to show you the rule-based workflow. So if you're not a big fan of, like manipulating all these proxies yourself, you can use this more I would say maybe human friendly way of creating a behavior. So here I'm in a different project now. Inside the simulation view, I'm going to select just a simple dining room. And now in this part of the presentation, I'm going to use this proxy rule set window. From window, Mars, proxy rule set. And let's open it and dock it somewhere in next to my hierarchy on the right-hand side. It's totally up to you where you place it. I actually prefer it to have on my left-hand side, or maybe docked together with the hierarchy. It's totally up to you where you place it. The most important thing is that it improves your life as a developer. So once we have our proxy rule set open, we can start adding different rules to our application. And you can see that when I click on add rule, we have this on every horizontal plane. And in the simulation view, you can see that we have this colored gizmo. We can actually change the color. I'm going to just stick to the original one, the blue color, and it detected a couple of them. You can check how many. It detected 6 of them. Is displayed here on the right-hand side. And you can kind of scroll through different environments and see in which places your proxies, your horizontal planes are being detected. So, of course, we can change it to vertical planes and other stuff. And the nice thing is that as you change it, the changes are reflected immediately in your simulation view. So it really speeds up the development time. And by default, it's set to on every, but you can also set it on up to. So maybe you can spawn 2 or 4 of them at maximum. And you can see that, yeah, right now we have only 4 gizmos in our simulation view. We can also set it to on 1. So there's only 1 there. And yeah, I'm going to drag and drop with this on every horizontal plane selected, I'm going to drag my robot on the plane here in the scene view. And you can see that automatically each one of these detected points, gizmos in my simulation view, they now have the spawn Unity robot. And we could also kind of define where on the plane we want to spawn it. So it could be a center, could be maybe like the closest point to the camera. So now if I switch to the device view, it should be basically the closest position to the camera on that particular surface, of course. The next thing I want to show you is the plane occlusion. Because as you'll notice, we have a small problem in our device view. And the problem is that let's switch to all of them on every surface. The robots, they are not being occluded by the real environment, right? So if you build it to application, all the chairs, all different planes, they're not going to occlude anything. So that's a huge problem. And to fix that, we need to add a couple of occlusion planes. To do that, we can go to the hierarchy or from the Mars panel. We can, in the hierarchy window, we can right click and go to Mars. Select the data visualizers and a plane visualizer. We can do the same thing from Mars panel. And you can see automatically it's created all these planes with kind of a nice hexagonal shape. So your user then going to see, the gradual expansion of the plane as they're being detected. If you don't want this hexagonal pattern, you can swap it with just the occlusion plane. So yeah, you can see that occlusion here is working, but it has this additional hexagonal pattern. Hexagons are nice, dots are fine as well. And they kind of allow you to see the scale a little bit better, but some people prefer just to have, the pure plane occlusion. So here, when we swap the plane prefab on the plane visualizer, it's going to be the pure transparent occlusion plane. And you can see that the robots under the table, they're being occluded by the tabletop. And it's all very nice. All right. And finally, next let me show you how to use an image tracker. So here I'm going to add on every image. I can choose an image from my image library. I've chosen this flower here. And the question is, how do we find it in our simulation view in the editor, right? So I just told it that on every image marker that is a flower, I will do something with that, right? So the answer to that is to create a synthetic image target. So here in my panel view, I'm going to click on the synthetic image target, set it to the flower. Right now it's a little bit small. And I'm going to set the size to the poster size to be slightly bigger. And I will try to align it somewhere in my simulation environment. So maybe rotate it by 90 degrees or so. So here 90 on the z-axis, 90 on the y-axis. And let's switch to the move tool and move it against the wall. Move it slightly upper here, and now it should basically react to whatever we do on every image marker. Whatever we assign to it, it should spawn as a child, basically, as a child object. So here I have some flowers. I'm going to drag them on that in the scene view to spawn them as a child objects. They're slightly bigger because here, remember, I adjusted my target to be the poster size. So I'm going to make them a little bit smaller, duplicate them a couple of times, and spread them kind of uniformly across the entire image marker. Just like that. And you can see that the changes are immediately reflected in our simulation view. If I would go to the device view or maybe to the play mode, this would happen gradually, and it will be spawned only once the image target is detected. But because we're in a simulation view, we see it instantaneously. And I really like this particular example because it's something that can really make your AR application much more believable and immersive. Just very nice overall. The next one I want to show you is the AR reskin. So it's an interesting use case, and the idea here is to procedurally add your content on top of the real world based on some rule sets. So here we can, take the table and replace the tabletop with maybe a grass or some rocks. On the floor, we can spawn water. Let's take a look at the example. So here, instead of recreating everything from scratch, I'm going to just show you how to use this build surface rule, and I'm going to show you just the finished thing. So here in the dining room, you can see that on every horizontal surface we spawn some grass. We use this build surface action that's going to build the grass. I can scroll and through different environments and see how well it will match my scenario of different conditions. So here you can see we have this nice kind of Japanese themed replacement. So on the floor we spawn some water. On one large surface we spawn the geisha character and some sand. Yeah. So this is really powerful, and if you want to create some immersive and fun procedural environment, this is very nice. And the next one is the location-based AR. So very often you want to align your application, align your AR experience with an image target. So this is this is something I'm going to show you here. So I use here my my kind of scene test environment. So instead of this pre-made kitchen and others, I just use my own. So this is, I have like a big skybox and a photogrammetry scan. It's a memory hall from San Francisco City Hall. It's just a nice photogrammetry scan that I want to align with my image target. So let's imagine that if you would go to this memory cord, we would place the image target there, and then once it's scanned, we would spawn all these different objects kind of aligned to my image target. And yeah, we have this nice overlay here. Just quickly disable the rule set so we can see just the photogrammetry scan. And really here on when we find this image target, we will spawn this 3D objects that kind of sit on top of the building. So we have this kind of sci-fi metallic edges to the building. Then we have this door arch proxy. So this is an interesting one because it uses the semantic tag. Semantic tags are really powerful. And on some devices like, iPad Pro, right now out of the box, we have things like floor detection, wall detection, door. So you could basically use the semantic tag to detect all these different places. Here it's kind of a cheating because we use the synthetic tag, and by synthetic it means that it's not real detection. I place some tags in my 3D environment, and the Unity Mars is basically looking for these tags. But as AR technology evolves, maybe in a couple of months they'll be able to use the semantic tag to detect the wall light and things like that. So this is the screenshot how it looks like. We have the synthesized object on the wall light, and it's a really nice way of working with Mars because it really allows you to work in a more procedural way. So instead of hard coding and placing them directly, lamps placing them directly at this particular position, you can add some indirection there and place tags wherever you want, and then you could easily swap the visuals in your rule set instead of directly placing and hard coding them in the fixed position. And the final part is the face landmarks. So here on every face proxy, I can basically detect different landmarks like eyebrows, eyes, mouth, and so on and so on. And here, before I was using the synthetic simulation environment, but I can use the recorded one. So yesterday I recorded my face here. I'm moving in front of the camera, and Mars is basically tracking based on this pre-recorded thing that I've done. Another thing is that I can switch to the live view. So here's me. I recorded it yesterday. It's basically getting the feed from my web camera. Okay, so I think that's basically it. So yeah, really by addressing these hard problems, tough challenges in many phases of our AR app development, Mars can come very handy and give you as a creator, the ability to deliver this AR experience that matches user expectation, maybe generate in a procedural way, and yeah. So here are some more links. If you don't know where to get Mars, you can go to the Get Started, click on that link right here. If you look for the manual, here's the link to the manual. And make sure to join our Discord channel. If you have any questions, we can continue the discussion there.